Modern factories and critical infrastructure rely on incredibly complex systems where physical machinery and smart software work together. When one of these systems, like a robotic arm on an assembly line, starts to malfunction, pinpointing the exact cause can be a massive headache. The traditional approach involves experts manually creating detailed models of every possible thing that could go wrong, a process that is slow, expensive, and often incomplete. Here's why this is important. Finding the root cause of a failure quickly is essential for safety and efficiency. A new research paper presents a clever solution that teaches machines to diagnose themselves, without needing a human to guide them every step of the way. Researchers developed an automated, three-step method to do this. First, their AI system listens to all the data coming from a machine's sensors at once. It looks for collective anomalies, subtle, coordinated patterns across multiple sensors that suggest something is amiss. Think of it as a doctor noticing a combination of symptoms rather than just a single one. Second, once the system flags a problem, it transforms the messy sensor data into a structured story, like a diary of events that describes exactly what happened during the failure. Finally, the system uses a powerful technique called process mining to analyze this story. It automatically creates a simple, visual map of the entire failure process. This map shows how one small issue can cascade into a bigger problem, step by step. By also including timing information, the system can run simulations to understand not just what went wrong, but how the failure unfolds over time. Let's explore what they found. The team tested their method on a public dataset from a robotic arm, a common benchmark for this type of research. The results showed that their AI was highly effective at automatically modeling, simulating, and classifying different types of faults. It successfully created clear maps of faulty behaviors without any prior knowledge or human labeling. So, what does this mean in practice? This technology could lead to smarter factories where machines can predict their own breakdowns and alert maintenance crews before a critical failure occurs. It enables the creation of fault dictionaries, which are like comprehensive guidebooks that help technicians quickly identify and fix problems. It can also be used to build more accurate digital twins, highly detailed virtual copies of physical systems that can be used for testing, optimization, and training without risking real-world equipment. If you enjoyed this breakdown, don't forget to like, comment, and subscribe for more AI research made simple.